Alright, so we're going to take a run at this second graph here. I made a note here. We're going to make no attempt to solve for the x-intercepts of this one because basically it turns into, like, it's bad. If we were going to try, we'd get this, which would mean this is true. And then I'd be kind of stuck. Like, I could turn it into an exponential maybe, but it doesn't get much better. So this graph has, I think, at least one x-intercept. I forget where. We'll just kind of estimate in our picture once we draw it. You'll see how it works. So it is a log graph. And again, it's going to have some domain issues. So anytime that is negative or 0, we're not going to have a graph. It's not going to be part of our domain. So we got to keep an eye on that. I tend to do that at the end after I've done my factor table. I sort of block off part of the factor table, which you've seen me do in other videos. But you could do it right away. It's totally up to you. So I'm going to start with my derivative. Derivative of a log thing is 1 over that thing, and then multiply by the derivative of the inside after the fact, so something like that. And derivative of x is 1. So I get 2x plus 1. And so what we're going to do is we're going to make a common denominator here. So we're going to turn that 1 into x squared minus 4 over x squared minus 4. And so what that derivative turns into is x squared plus 2x take away 4 over x squared minus 4. And I can actually factor that denominator. I might as well do that now to x minus 2 and x plus 2, because we're pretty much ready for our factor table, because we'll look, that top does not factor. So what I'm going to do is I'm going to get the potential x-intercepts from that, from the quadratic formula. I should say the potential horizontal tangent points from the quadratic formula. E squared minus 4ac all over 2a. Uh, 1.2 we'll say, or negative 3.2 it looks like for my two answers. Just double checking that first one. Yep, okay, we're good. So we're ready to go to our factor table for the first derivative. And on that factor table, we put anything that makes any part 0, so the top or the bottom. So we have those two numbers from the quadratic formula. We also have plus or minus 2. So negative 3.2, negative 2, 1.2, and 2, and off to infinity. And so we have that quadratic on top, which opens up. We've seen this a few times. If it opens up, it's negative between its x-intercepts, which are the decimal numbers from the quadratic formula. We have an x minus 2, which switches at 2, and an x plus 2, which switches at minus 2. So we have that. And then maybe here is where I'll think about my domain. So we have x squared minus 4 in the inside the logarithm. Again, that's a quadratic that opens up. So it's going to be negative between its x-intercepts, which are the 2 and the minus 2. So this whole graph will not exist between minus 2 and 2. So we've got no man's land there. And the borders of that region will be vertical asymptotes, because that's where we'll be doing the log of 0, and that's what makes the vertical asymptote on a log graph. So from there, I'll fill in the rest. This is my first derivative. So it's increasing, decreasing, doesn't exist, and then increasing after it doesn't exist. But we do get a maximum point at negative 3.2. It's a maximum with a horizontal tangent because the numerator of the derivative was 0 at negative 3.2. So I'm going to want the point for that, so I'll plug that into my original function. I think it was plus x, right? Yeah. So I believe I get a grand total of negative 1.37. We'll call it negative 1.4 once we do all that. So there's our maximum point. And then 2 vertical asymptotes, and that's all we get from the first derivative. Now I'm going to do the second derivative, and I'm going to look at f being, so it's a quotient rule, just a plain old quotient rule. So f is going to be that. And when I'm considering g, it's easier to consider the x squared minus 4 rather than the factored version of that. So we're going to get f primed times g minus g primed times f all over g squared. Okay. And I look at the numerator. Unfortunately, we don't really have anything in common to factor out, so I'm just going to multiply that out. We're going to get a cubic, but just peeking at the cubes are going to cancel out, so that'll be nice. So 2x cubed minus 8x plus 2x squared minus 8 from that first part. I'm going to consider this to be a negative 2x when multiplying it through that bracket, so negative 2x cubed, negative 4x squared, and positive 8x, I believe, is what we have, over the x squared minus 4 all squared. And then, yeah, the cubes cancel out. That's handy. I see negative 2x squared on top. These actually go away. And then I just see a minus 8 over x squared minus 4 all squared. So I can actually, this looks like it'll be nice. The negative 2 cancels out. X squared plus 4, not cancels out, but factors out. And I think that's my numerator is fully factored there. We can work with that. I'm just going to factor that denominator again. So you get x minus 2 times x plus 2. You get that squared, so you get each of these brackets squared on the bottom. So we're ready for our factor table for the second derivative, because all we have is the 2 and the minus 2. Because that top x squared plus 4 is never going to be 0. It's always going to be positive. And we already know that that's the region that doesn't exist. We know these are our vertical asymptotes. So we've got a negative 2, which is always negative. We've got an x squared plus 4, which is always positive. And the denominator is 2 things squared. So since they're squared, they're never going to be negative. So we are always concave down on this graph. So I'm going to do my combined table, which should have all the numbers from both table, which just translates to all the numbers from the first table on this one, because the second table didn't give us anything new. In fact, I'm going to be lazy and make my combined table. I'll just add, since we're not getting any new intervals, I'll just add the second derivative up to this table. because it was always negative anyway. And then I'll get my shapes. So increasing concave down, decreasing concave down, yep, and then increasing concave down, something like that. So there's my two vertical asymptotes at -2 and 2, -3.2 and -1.4, so somewhere over here. That's my maximum point. And we don't have much going on. We've got this shape up to that max, flattened there, that shape down from that max. So something like that into that vertical asymptote. And then after the vertical asymptote, we have this shape here. There's no horizontal asymptotes on this graph. So like I said, this one, it's gonna eventually cross the x-axis. I actually don't know how to find that point at all. I'm sure it would be some sort of numerical method that I've forgotten how to do, but that's kind of what this graph should look like. And again, I'm not really sure where that x-intercept is there, but I know there should be one there somewhere. That's the